Good afternoon, everyone, and welcome. My name is Valentina Lodi, and I'm pleased to welcome you today for the special webinar about our new Tarnish-Resistant alloy, LUX276. So let's get started. The session will open with a short introduction about ProGold to provide some context and background before we move into the core of the presentation. We'll then take a look at how tarnishing has historically been a challenge for silver jewelry, and I'll walk you through the key feature of LUX276 and its tarnish resistance. Finally, I'll share you some practical information on how to purchase the product. And we will also have time at the end for a live Q&A session, so please feel free to send in your question using the chat feature at any point. But firstly, let me introduce myself. My name is Valentina Lodi, R&D Manager at ProGold. I hold a master's degree in material science and a PhD in nanotechnology. I have been with ProGold since 2015, where I've always been involved in research and development, both in jewelry, master alloys, and additive manufacturing. For those who are not yet familiar with the work of ProGold, let me give you a brief overview. ProGold was founded in 1997 and has since grown to become a global presence. Today, we operate in all major markets around the world, with a dealer network spanning 16 countries and exports reaching over 50 nations. Our expertise is structured around three main business areas, which represent the core of what we do: alloys and master alloys for jewelry, soldering solution, and service bureau for direct precious metal 3D printing. At ProGold, we truly believe in innovation. More than 20% of our people work in R&D, where they focus every day on developing new formulation and testing. This commitment has led to the creation of a cutting-edge laboratory equipped with state-of-the-art instruments and a highly skilled team. We also collaborate with universities and research centers, and we take part in international seminars. All of this with one clear goal: to meet the evolving needs of the market. The goal of today's webinar is to introduce you to one of the latest products born from our innovation process, LUX276. It's an alloy specifically designed for high tarnish resistance, and together we'll explore how it stands out from other alloys on the market. Why did we decide to develop this kind of product? Because tarnishing is one of the biggest concerns in silver jewelry, and there is a growing demand for long-lasting, durable silver pieces. But current solutions often come with limitations. They are either too expensive or they don't offer high enough resistance. That's why there is a clear need for a solution that is reliable, efficient, and accessible. LUX276 is a ready-to-use alloy, which means it guarantees a certified silver title, is made from 100% recycled material, and is COC certified. It also ensures lower impurity levels, resulting in better casting quality and an improved surface finish. On top of that, it's time-saving. No need for separate alloying, which means one less casting step. And that also means lower energy consumption and reduced CO2 emissions during production. So, what makes LUX276 stand out? It offers superior tarnish resistance compared to standard alloys without relying on expensive elements like palladium or platinum. We use the term tarnish-resistant rather than anti-tarnish because tarnishing is a phenomenon that can be more or less rapid depending on the alloy composition, but it can never be completely eliminated. LUX276 is ultra-hardenable and require no galvanic treatment, all without driving up cost. In short, high performance, simple process, accessible price. To make the advantages of LUX276 crystal clear, I'm going to show you the result of an accelerated tarnish test. This test was custom designed to simulate real-life tarnishing conditions. It's a comparative test conducted in a controlled laboratory environment. The test lasts 15 minutes. The samples are hung inside the chamber and a small plate containing potassium sulfide is placed inside. Hydrochloric acid is then added to the plate to initiate the chemical reaction that produces hydrogen sulfide gas. This gas permeates the chamber, creating a sulfur-rich atmosphere in which the samples are exposed. The comparison was conducted between LUX276, a silver alloy with silicon, and the sterling silver. The video has been time-lapsed to condense it into under 1 minute, but as I mentioned earlier, the actual duration of the test is 15 minutes. Let's now move on the video of the test. As we observe the progression of the test, it is important to keep in mind that tarnish is a complex phenomenon. It involves several chemical reactions caused by multiple environmental factors like heat, humidity, sulfur concentration, and light exposure, which lead to a visible change in the color of the jewelry. It's the fact that the same piece of jewel, when worn in different environments, for example, in areas with different level of heat, humidity, pollution, or even in thermal bath, will tarnish at different rates. Reproducing this behavior in a laboratory through an accelerated test is not easy. In our lab, we choose to adopt a comparative test based on exposure to a sulfur-saturated atmosphere, as sulfur is likely the main factor responsible for tarnishing in silver alloys. We'd also like to point out that some tests used to assess tarnish resistance, such as self-spray tests, are not actually designed for this specific phenomenon. While these tests evaluate similar properties, such as corrosion resistance, they are not equivalent when it comes to measuring real tarnish behavior. Looking at the picture taken before and after the test, it is clear that the color variation is lower in the case of LUX276 compared to both the sterling silver and the silicon-containing alloy. This observation is also supported by the measurements taken with the colorimeter before and after the test, where we report the variation in CLab coordinates for the free alloy under analysis. To conclude, some general information about LUX276. It's a ready-to-use alloy with silver already included. It's available for purchase on our website. You will need to log in. On our website, you can also find the full technical specification and usage recommendations. Since LUX276 is a ready-to-use alloy, its final price depends on the current silver market. For an accurate and up-to-date quotation, we invite you to visit our website or contact your local ProGold representative. And finally, a minimum order quantity of 500 grams is required. Let's now move on to the Q&A session. Given the limited time available, if any question requires a more in-depth response, we will make sure to follow up with you directly after the webinar to provide a complete answer. We'll now take a short 2-minute break to give you a chance to enter your final questions, and we will be back shortly. Welcome back. So we start with the first question. Is this alloy worth for jewelry with stone in place during casting process? Yes, the answer is yes, absolutely, because it's like I already mentioned, is a LUX, yeah, so basically, absolutely yes, also for stone in place. Second question, is it suitable for continuous casting for tube production? Okay, this alloy was designed for investment casting, but actually we are also testing also the mechanical deformation, and we have a value of elongation really promising. So we are doing our test, but yes, we will be back regarding this in the near future, but it seems promising also for continuous casting. Another question, tarnish life expectancy. Oh, this is let's say that this depends a lot on where you are. As I said before, if you are in a very clean environment, like on a mountain, maybe you will never experience tarnish on your jewelry. If you are in a polluted area with a lot of sulfur, actually, or near the sea, or in you go to the therm, for example, the thermal bath, you will, I think, experience some tarnish for sure after some times. So it's difficult to answer to this question because it depends really a lot on the environment where you are. This is also why we try to reproduce the real life behavior of the alloy, but even real life actually means real life here where I test the material, not everywhere. Yes, okay. Next one is, it is fragile. No, we know that mainly one of the problem of, sometimes at least, with the anti-tarnish alloys for silver is that they suffer from a little bit of fragility, but no, this alloy doesn't suffer from fragility. This is why we need to study it also with the mechanical deformation, because it's really promising even in this, because we have no fragility. Next question, any solder powder available with same good tarnish resistance? This is a really good question, because of course when we go to soldering powder, of course the composition is another story. So at the moment, no, or at least we have to try and make tests. But if you are interested in this, we can for sure develop together something and at least make some tests and see where we can arrive. Okay, then we have, is there a minimum order quantity to buy try? Yes, as I already said in the presentation, we have a minimum quantity of 500 grams. So this is also the minimum quantity for any trial that you want to perform. I think, yeah, this was the last one, so we finish. So I thank you again for your attention and for your time. It was a pleasure to have you here today, and thank you again, and goodbye.